let's say we have a linear equation, and we know when x is equal to 4, that y is equal to 9, and we've plotted that point here on our xy plane. Actually, I forgot to label the x-axis right over there. And let's say we also know that when x is equal to 6, y is equal to 1. And we've plotted that point there. And so this green line represents all of the solutions to this linear equation. Now what I want to do in this video is I want to say, well, can we find that linear equation, and can we express it in both point-slope form and in slope-intercept form? And I encourage you, like always, pause the video and see if you can do it. So let's first think about point-slope form. Point-slope form. And point-slope form is very easy to generate if you know a point on the line, or if you know a point that satisfies where the x and y coordinates satisfy the linear equation, and if you were to know the slope of the line that represents the solution set of that linear equation. Now for sure, we were given 2 points that are solutions, that represent solutions to the linear equation. To fully apply point slope, or to apply point slope easily, we just have to figure out the slope. And what we could do is we could just evaluate, well, what's the slope between the 2 points that we know? And we just have to remind ourselves that slope is equal to change in y over change in x. Sometimes people say rise over run. And what's that going to be? Well, if we say that this second point right over here, if we say this is kind of if we're starting at this point and we go to that point, then our change in y going from this point to that point is going to be equal to 1 minus 9. 1 minus 9. This point right over here is the point 6, 1. So we started at y equals 9. We finish at y equals 1. Our change in y is going to be 1 minus 9. We have a negative 8 change in y, which makes sense. We've gone down 8. So this is going to be equal to negative 8. That's our change in y. And what's our change in x? Well, we go from x equals 4 to x equals 6. So we end up at x equals 6, and we started at x equals 4. So our change in x is 6 minus 4, which is equal to 2. And you could have even done it visually. To go from this point to this point, your change in y is you went down 8. So your change in, let me write this. So your change in y is equal to negative 8. And what was your change in x to get to this point? Well, your change in x is positive 2. So your change in x is equal to 2. And so what's your slope? Change in y over change in x, negative 8 over 2 is equal to negative 4. So now that we know the slope, and we know a point, we actually know 2 points on the line, we can express this in point slope form. And so let's do that. And the way I like to do is I always like to just take it straight from the definition of what slope is. We know that the slope between any 2 points on this line is going to be negative 4. So if we take an arbitrary y that sits on this line, and if we find the difference between that y, and let's focus on this point up here. So if we find the difference between that y and this y, and 9, and it's over the difference between some x on the line and this x and 4, this is going to be the slope between any xy on this line and this point right over here. And the slope between any 2 points on a line are going to have to be constant. So this is going to be equal to the slope of the line. It's going to be equal to negative 4. And we're not in point slope form or classic point slope form just yet. To do that, we just multiply both sides times x minus 4. So we get y minus 9. Is equal to our slope, negative 4, times x minus 4. And this right over here is our classic point slope form. We have the point. Sometimes they even put parentheses like this. But we could figure out the point from this point slope form. the point that sits on this line would be things that make both sides of this equation equal to 0. So it would be x equals 4, y equals 9, which we have right up there, and then the slope is right over here. It's negative 4. Now from this, can we now express this linear equation in y-intercept form? In y-intercept form, just as a bit of a reminder, it's y is equal to mx plus b, where this coefficient is our slope, and this constant right over here allows us to figure out our y-intercept. And to get this in this form, we just have to simplify a little bit of this algebra. So you have y minus 9 is equal to, well, let's distribute this negative 4. And I'll just switch some colors. Let's distribute this negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 4 is plus 16. And now if we just want to isolate the y on the left-hand side, we can add 9 to both sides. So let's do that. Let's add 9. Let's add 9 to both sides. Let's add 9 to both sides. On the left-hand side, we're just left with y. And on the right-hand side, we're left with negative 4x. And then 16 plus 9 is plus 25. And there you have it. We have the same linear equation, but it's now represented in slope-intercept form. Once again, we see the slope right over here. And now we can figure out what the y-intercept is. The y-intercept, when x is equal to 0, y is going to be equal to 25. My axis right here, I haven't drawn it high enough, but if I made it even taller and taller, and you see that's this line is going to intersect the y-axis when y is equal to 25. So there you go. We wrote it in point slope form. That is that right over there, and we wrote it in we wrote it in slope. We wrote it in slope-intercept form. Point slope and slope-intercept. Hopefully you enjoyed that.